So we're going to do a simple, quick construction of a parallelogram without actually constructing parallel lines, using the first property of parallelograms that the opposite sides are congruent. But first of all, a little known fact. Vikings would often use a pencil attached to one of their horns in order to do construction. Now, I bet your history teacher will never tell you that little factoid. Now here we have an angle ADC, and we want to construct parallelogram ABCD, right? So really what we're doing is we're looking for point B. If we find point B, then we will have a parallelogram. Using the first property of parallelograms, we know that AD is congruent to BC. So let's go ahead using our compass. Let's set the compass setting to the measurement of AD, and then let's move the compass over to C. B has to lie somewhere on this arc. We also know that DC has to be congruent to its opposite side, which would be AB. And with that piece of information, we can find the intersection and locate our point B. Now, again, to review, you're taking DC is congruent to AB, and DA or AD is congruent to BC, right?
AB is parallel to DC and AD is parallel to BC. It also means that they are congruent, that AB is congruent to DC, AD is congruent to BC. It means that angle D here is congruent to angle B, right? Second property, opposite angles are congruent. C and A are congruent angles. And then it also means that the diagonals bisect each other, right? In other words, this segment is congruent to this segment is congruent to this segment. And finally, it means that the consecutive angles are supplementary. They add up to 180, which we can easily prove that consecutive angles are simply same side interior angles, right? Which we already know are supplementary. Again, we've shown that AB is parallel to DC and AD is parallel to BC, and we didn't have to construct any parallel lines.